Hi, my name is Kasun and I'm a postdoc with Professor Jens Nørskov. I'm passionate to develop a research group with a focus in computational catalysis and machine learning guided catalyst design and discovery for energy applications. Uncertainty over the future security of our energy is a major concern with the rising global population, increasing energy demands, and impending climate change. My research vision is to overcome the aforementioned challenges in the short term, improving energy efficiency for existing processes. In the long term, a transition to a society based on CO2 neutral sustainable energy resources. These processes and devices rely strongly on catalytic materials in order to attain the required performance involved in the operation. However, today's catalytic materials are inadequate. Therefore, the grand challenge is to design and discover advanced catalytic materials that satisfy activity, selectivity, stability to achieve a sustainable energy future. The overarching goal of my research is to develop innovative strategies to produce renewable energy fuels and chemicals by the computational design of efficient thermo and electrocatalytic processes. To achieve this, I combine my expertise in the fields of computational catalysis, kinetic modeling, and machine learning, with a special focus in underpinning the structural property relationships of advanced catalytic materials to accelerate material discovery and establish catalyst design principles. Along with these theoretical insights, I collaborate with leading experimentalists for testing and validation. Here's a brief overview of proposed research as a faculty candidate. Theme 1 will be on operando computational catalysis. Theme 2 would be on machine learning approaches to accelerate catalyst discovery and design. So during my PhD with Professor Mark Saiz and Gipi Mara, I studied the reaction mechanism and microkinetics of the Cowell catalyzed Fischer-Tropsch synthesis. First, I identified the realistic surface and the reaction conditions, then the nature of active sites for CO activation and role of water by investigating the detailed reaction mechanism, a complex combination of carbon-carbon bond formation, CO scission, hydrogenation steps, and products formation. I developed a dual-side microkinetic model and investigated the product selectivity, activity, and introduced catalyst design principles. My second project focused on tuning the catalytic activity via defect engineering for CO oxidation and ethylene hydrogenation. I successfully demonstrate controlled charge transfer between support and small metal particles by both theory and experiments. During my postdoc with Professor Jens Nørskov, I developed high throughput stability and activity screening framework to accelerate material discovery. Furthermore, I investigated oxides and MXCs, supported single atom catalysts for oxygen electrocatalysis, and developed descriptors for stability and activity using machine learning approaches. I identified the nature of active sites and introduced design principles for silver-based first-order transition metal bimetallic catalysts for alkaline ORR in collaboration with Professor Hermiou's group at Stanford University. My ultimate teaching goal is to act as a catalyst to inspire the next generation of students. I have always enjoyed teaching, and my teaching philosophy of learning by doing and interdisciplinary collaboration aim to enable my students to connect fundamental chemical engineering and chemistry concepts and real-world applications. I'm open to teaching core chemical engineering courses and keen on developing two new courses, fundamentals of heterogeneous catalysis with applications in energy transformations and data science for chemical engineers. As a first generation college student and a Sri Lankan who has lived in multiple countries, I'm sensitive to the challenges that ethnic minorities face in academia. Therefore, over the last years, I have become determined to act towards creating an environment that is more inclusive towards underrepresented minorities, women, and marginalized students and scientists. So these are some of the proposed activities. I believe that my skill set makes me a strong candidate as a professor who specializes in catalysis, kinetics, and machine learning. I look forward to discussing my research with you. Thank you.